Here's a fun infiltration experiment you can do in winter. I took 3 bottles with ice cold, room temperature, and hot water, mixed in some food dye, then emptied them into the top of a snowbank. The goal was to see if the temperature changed how the water moved downwards, and how that compared to real infiltration in the ground. After a few mishaps, all the bottles got emptied, and I left it overnight to settle. Alright, so it had a day to freeze. Let's see how we did. The benefit of doing this with snow is that we can really dig down and see what happened, which is often impossible with soil. After a lot of shoveling, we can start to see the normally hidden parts of this story. All 3 colors eventually got to the bottom of the 1 meter deep snowbank. The green hot water drilled a hole straight down to the ground, but then flattened out at the bottom when it hit the frozen soil below the snow. We see similar patterns in real soil infiltration, when contaminants seeping downwards hit a more tightly packed soil layer. The same thing happened in my hometown of Manotick, where dry cleaning fluid contaminated our drinking aquifer. On the opposite end of the experiment, the blue ice water didn't create a vertical hole, but because it couldn't travel quickly vertically, it also spread out more throughout the snowbank. Finally, the red room temperature water melted a small hole at first, but eventually slowed. More interestingly, when the spreading blue water reached the red seepage, it shortcut along the same flow path. We have this same problem in real life, where contamination travels more quickly down old wells that have been forgotten or abandoned. A similar vertical shortcutting led to an E. coli outbreak in Walkerton, Ontario in May 2000. That means old abandoned wells like this one near my house represent a big risk for groundwater contamination. It's neat how a little food dye in a snowbank can remind us what happens beneath our feet, and how better understanding comes from digging just a little bit deeper.